Hi roboticist, we are handing over from the last video where we have found, thanks to our RV's visualization, the joint angle for our cobots that allows the end effector to reach the object that we have spawned in our world, or better in our gazebo world. So now what we're gonna do is to open our gazebo environment, and we're gonna use our RQT GUI to give to our robot the joint angle that we have found in the other video. Okay, so let's open the RQT GUI. And I remember you that the joint 1 position controller is gonna be 0.47, then the joint 2 is gonna be 1.22. I remember you that the values are in radians, then joint 3 0.81, joint 4 position controller 0.52, joint 5 minus 1.46, and joint 6 0.51. So let's play the environment. Then we're gonna tip the joint position controller, and you can see that the robot is gonna reach as forward kinematics the position that we have founded in RVs. Okay, so you can see now that the TPC is really approached to our object. And then, as you can see, if we zoom in, we can see that the end effector is really approach to our cube that is spawned, remember you, in 1, 1, X and Y position respectively. And the bottom of this cube is laying at the surface, or better at the floor of our environment, and you can see that the grippers here has the same height of the cube, so we should be able to grasp it. And for doing that, let's move the joint 1 position controller by 0.1, and you are gonna see that the joint 1 position controller is moving towards the cube. Okay, and now you can see that the cube is perfectly in the middle of our grippers. And so now if we move our gripper left and the gripper right, you will see that the gripper is going to grasp the object itself. So now what we can do is to try to move this cube in another position of the environment, and for doing that let's move the joint 2 position controller. So let's raise it a little bit and see what's happened, and then we can change. Okay, now you can see that the cube has fallen down, so meaning that there's some problem in the environment, so that it seems that even if we have set a good position for the grippers, it seems that the cube is not attached to the gripper itself, meaning that we need to improve the grasping. and this is dealing with the damping effector and the friction tag of our URDF file that we are about to update. And so we are gonna solve this problem right away. And I'm gonna teach you a method that allows you to grasp correctly the cube or any object you might have in your environment. Okay, so what we're gonna do is to create another URDF file, and we're gonna call it gripper.xacro. So it's gonna be a xacro file where we are gonna to model a gripper that will have the same shape as we have in our cobot.urdf file, but this time the grippers will have other features and that will allows us to solve the grasping problem that we have seen so far. And we're gonna deal with this gripper as a macro, a huge macro tag that we're gonna name gripper, and of course it will need to have the parent link as a parameter, and the origin, meaning that the origin will set where we're gonna put the gripper. And this is very useful in general to dealing with this, to dealing a gripper in a separate xacro file, or better a macro, because you can model your 6-axis robot, 3-axis, doesn't matter. And since that the gripper is gonna be very particular, but you might have a gripper or another kind of end effector, is better, always better, a good practice to model in another file. So the TCP connector that we have modeled in our cobot.urdf file in our gripper xacro file is gonna be gripper connector. And as well as in the cobot file, URDF file, we have modeled also the joint. We need to do the same in the xacro file as well. So what we're gonna do now is to create a joint that we're gonna call it gripper joint, is of type Revolut. And of course there will be the parent link and the child link, the gripper connector, and we can just copy and paste the axis, so where this joint will be the axis of rotation and will be Z. Then we can copy and paste the limit, lower, upper, velocity in effort, and the origin as well. And this time we're gonna adding some dynamics properties like damping and friction. And so if you remember well, when you model a robot, you have the link, you have the joint, and then you have the transmission. So we are gonna create the transmission tag that we're gonna call it the trans gripper joint, and that this transmission is related to the gripper joint that we have modeled so far, and the actuator name is gonna be motor gripper joint. So we have modeled our connector, then we can do the same approach for the gripper right and the gripper left as well. So we are gonna keep the same value that we have set up in the URDF file, but this time the only difference will be that in the joint in the joint tag we need to add the dynamics properties, damping and friction. So as of now we have created our gripper xacro file in the same way that we have modeled in our cobot.urdf file. So here nothing's changed, with the exception that we have added the dynamics tag in damping and friction, and what we have added so far is the mimic tag. So in particular in the gripper left joint we have set up a mimic tag where we have put as a parent joint, let's say gripper right joint, and the gripper left will be the joint that will, let's say, copy the behavior of the gripper right. And as you can see, we have set up a multiplier of minus 1 and offset 0. So how this mimic behavior will look like? So in the previous setup, what we needed to do is if you wanted to close the gripper, we needed to set in the right position the gripper left and the gripper right as well. When we are using the mimic tag and the mimic plugin, what we will need to do is only to control, in this case, the gripper right, and the gripper left will act accordingly. So for example, if we are gonna set the gripper right joint at the 0.05 position, the gripper left will automatically set the position to minus 0.05. Why minus? Because we have put a multiplier minus 1. So we have put our mimic tag in our gripper left joint, and now what we need to do is to put the ROS control plugin for mimic. So when you have to deal with a plugin, I always suggest you to copy and paste the piece of code that is available in most likely in GitHub, or for example I remember you that in this video I'm gonna put the link of my repository, so you just can copy and paste. Why that? Because sometimes when you are playing with ROS, you just need to use the tools that are already available instead of reinvent the wheel. And this will be a nice example where we are going to use the plugin that is already available from the ROS libraries. And so just copy and paste, and we are gonna set a macro that name mimic joint plugin Gazebo, and then you need to remember to update the namespace to the same name of the robot namespace that we have set up. And the magic will happen inside this Gazebo tag. And I remember you that when you find a Gazebo tag is meaning that there will be some physical properties in that, so your ROS code will interact with the Gazebo physics environment. So what we need to do for use this plugin is to set up the parent joint, the mimic joint. You need to set up if it has a PID values, the multiplier, the offset, and so on and so forth, and the namespace. So inside this Gazebo tag, which is very important, as you can see, we are gonna use libraries set up in the file name librobotics group Gazebo mimic joint plugin.so, and I remember you that you need to download the repository from GitHub. I'm gonna put the link in the description down below, and but in any case I will let you know how to clone a repository from GitHub. We're gonna talk about this later. So in our case, the parent joint will be the gripper right joint, and the mimic joint will be the gripper left joint, meaning that in our control environment we will need only to control the gripper right joint, and the gripper left will act accordingly depending on the multiplier or the offset that we have set. In this case we have set up an offset of 0 and a multiplier of minus 1.0, is meaning that if, for example, you're gonna have a value of 1, an example of a gripper right, the gripper left will be set up at minus 1. Then for PID we don't need to use it, and the multiplier, I remember you that is gonna be minus 1. Last thing before closing this xacro file, we will need to add this plugin, Gazebo plugin. And this Gazebo plugin is very useful if you don't want that your object is going to fall down when you're gripping. So of course, if you want to use this, you need to download the repository, and in this plugin you can see that we're gonna use the libgazebo graspfix.so library, and you just need to put the tailored parameter, so the arm name, the palm link, gripper link, gripper right, left, and all the value that you can see displayed here. So before diving into the simulation, I just remember you that if you want to use this plugin, you need to clone the repository in the source folder of your Catkin workspace. This is very important to do, and then you need to build the package as well by typing Catkin make. So you need to download a free package that is displaying here, and but don't worry about that. I'm gonna put the link in the description down below of this video. Okay, so now that we have set up our gripper xacro file, we will need to update our cobot.urdf file, so we can comment out the links, transmission, and the joints that we don't need anymore because they are set up in the gripper xacro file. And of course we need to include our gripper xacro. So we are gonna use the gripper as a parent link. It's gonna be the link 5, and then we can set up the origin in X, Y, and Z, the same that we have set before. Okay, remember to follow the dummy arrows that I've done, but don't worry, in the repository there will be the updated one, so you just need to download and test it in your computer, in your machine. And then let's run the simulation. And let's see that if it's working. So as you can see, the gripper are in the position 0 and 0, and then you can see that now if we are setting up the gripper right position controller only, command topic as 0.05, you can see now that also the gripper left position controller command will act accordingly and will go to minus 0.05, and this will close the gripper as well. So now you have seen the capabilities of this mimic modeling of gripper, and now we are gonna try to pick the cube that we have modeled so far. And what we need to do now is to reach with the gripper the position that will allow the gripper to, well, actually grasp the object, so we can put the value that we have founded in the last video. And then let's update the joint value as before and see what happens when we are trying to close the gripper. Okay, now the object is grasped. So now what we can try to do is to change the joint value to see if now the object falls down. And as you can see, a part of this backlash of this robot, now if we change the value of the joint 2 position controller, joint 1, and so on and so forth, you will see that the object will be grasped very well to the gripper. and this is thanks to the grasp fix libraries that we have used in our gripper xacro file. As you can see, the grasping now works fine, and it seems that it's very stable for simulation purposes, I will say. And now, for example, we can try to place somewhere else in our environment and release the grasping. So feel free to try. And now the object is approaching the floor of the environment, and now what we can do is to release the object and see what's happened. And to do that, we just need to set the gripper right position controller to 0. So let's have some modification here. For example, let's try out the joint 5 position controller. Let's change the joint 6 position controller. Okay, now the object is oriented with the base of the cube parallel to the floor, and then we can release, just put in 0, and you can see now the object is falling down. And after that we can return back in our 0 configuration for the robot. Okay, that's all for today. I hope that you enjoyed this video. This was a very funny one because we have started to play with robots and objects. And so, in particular, as the key takeaway here from this video is that now you should be able to find the joint values that allows your grippers to approach the object that you want to take, and then you have seen how to model a simple gripper with sliders and using the mimic tag for the gripper, and you should be able to use the libraries for the mimic properties and for the fixed grasping as well. So in such a way that you should be able to pick an object from anywhere of your environment and place whatever you want. And we have made an anticipation of what is called forward kinematics. That is meaning that you need to put the joint value, and the TCP, or better the gripper, will reach a certain position. Of course, this method that you have learned is not a practical one, because it's not automated one. It's more like try and errors. And what we will learn in the next video is to create our Move8 package for our robots. And we are gonna try to pick and place from a node, so writing a node of forward kinematics, and later on we are gonna talk about inverse kinematics, which will be very interesting one. So I don't want to anticipate nothing more. Again, thank you for your attention, and I'm looking forward to see you in the next video. And as always, keep learning robotics with Ross.